Okay, so this is the number 4 of the Superfluid Protocol Forum. And this week we will review the progress of ACL. So Vincent will do a code review together with us about the new implementation. So Vincent, then maybe you can share your screen.
You guys can see my screen? Okay. So I guess the best place to start. Can you hear me, by the way? Or no? Okay, cool. Yeah. So the best place to start, I guess, is the actual updating of the permission. Everyone knows what ACL is. I'm just going to assume that. So first, we have this pretty general update flow operator permissions. So you pass in the token you want to update the permissions for the sender, the flow operator, and then the permissions and flow rate allowance and context. And we're passing in context for all of these because we're, I'm assuming once again that we're going to be calling this through the host contract. So you still have to do call agreements on all of these. Yeah. This is interesting here. The permissions are it's going to be represented as a uint8, but it's a bit mask representation of the granted permissions. We're only going to be using 3 of the 8 bits. So if position 0 is 1, it means you can create the position 0 and 1 are both 1, then you can create an update and so on.
Might be good to actually document where the definition is of that permission in the definition.
True.
Yeah.
Vincent, on the permissions, so there's 8 bits and you're only using 3 of the slots. Could you repeat what each bit represents in terms of permissions again?
Yeah, so that's documented in this file. I'll just jump there real quick. Over here. So we're using the rightmost bits, so 0, 1, 0, 0. So that stands for create, update, and delete. So if this is 0, it means you don't have permission to do it. But if it's 1, then you have permission to do either action.
Isn't the definition file a better documentation instead of looking at the code?
Yeah, leaving like definitions.sol.
Yeah, did you define the bits there?
I don't think I did this image thing, but I have something else there.
But wait, the permission bit is it documented in the definitions?
Yes.
Okay.
Maybe.
Yeah.
I mean, here, yeah, 0, 1, 2, right? So, but this is not really necessary, I guess. But yeah, anyways, yeah, you can look at these for reference. Okay, so I don't need to add this. And these 2 functions are basically wrapper functions. They both call this, but the difference is that we're just giving them all permissions, create, update, delete with the maximum flow rate. So this is when you really trust the person, you're just giving them full control to create, update, delete at the maximum flow rate, which is just a 96 max. And similarly here, you're removing all controls from the flow operator. So now they can no longer do anything and their flow rate allowance is set to 0. These are just getter functions for getting the actual flow operator's data. This just returns a permission and flow rate allowance. And I guess it's a good thing to mention that the flow rate allowance, the way it works is that, like, let's say you grant someone 100 per second flow rate allowance. If the flow operator uses up 50, so they create a flow, now they have 50 less. If they delete this flow, it still stays at 50. It doesn't go back up or anything. It just remains there. If you update the flow rate to something lower than 50, it still stays there. If you upgrade it to the same amount, it still stays there. If you upgrade it to a higher amount, then that's when it does consume more of the flow rate allowance, which actually just made me think of a new test case that I got to write up.
Vincent, could you repeat that real quick? So if you have 100 flow rate allowance, and then suppose you use up 50 of it, and then suppose you delete that 50 flow, then will you still have the initial 100 buffer to play with, or will you just have 50 to play with?
You'll just have 50 to play with. And the thing is, I'm thinking about it now, right? Like let's say you started at 100, you decreased it to 50, or you start at 100 allowance, you create a flow for 50, you decrease it to like 25, and then you increase it again to 50. Like the way it's written now, you would subtract another 25. I don't know if that's correct though. I mean, maybe it is, but
it's up to us, but I think that's fair to do that.
Fair?
Each time you,
okay.
Yeah, it's time you do a delta that is positive, you basically
You have to pay.
use allowance. Yeah.
Okay.
Yeah.
And I'll also add a test case for that.
So let me add Elvis. Actually, he might use one that actually need to understand this behavior. Sorry.
Wait, just one thing, Vincent. Maybe I'm just not completely understanding it, but if you use a 50 flow rate and then the flow rate goes back down to 0, how come you don't have the initial 100 to play with?
Because you've used that's where the naming comes in.
It's like a 51 time shot. Okay, so it's like a
So if you want to, for example, re-up basically, then you would just call this update flow operator permissions again, or you could just call this. There's another thing which I'll go through in the actual implementation, but if you have set max flow rate for the flow operator, it just stays at that level and it never drops. So like no matter how much they update the flow rate allowance or create flows for you, it never decreases their allowance.
Okay. Okay, maybe I assume there's a good reason for this, but is there some way where, let's say you give 100 buffer allowance, like the operator can always have that 100 to play with. Let's say they create a flow and then they delete a flow, but kind of the total flow rate which the operator can kind of play with on the behalf of someone else is 100. This seems to me a little more intuitive, but I'm not sure. Am I missing something here? Or
you mean like they're able to? Can you say that again? Sorry.
Yeah. So if you give 100 allowance to someone, and they create a flow for 50, and then they delete a flow for 50, I think they should be able to always have the 100 allowance to play with. So it's sort of like it's more like a continuous kind of range which they can always keep operating in.
Yeah, so the reason is because it was hard to track, because anyone or either sender or receiver can delete it. Then what's the semantic, right? Do we keep track of it? If they delete, they don't give. Yeah. So we give this kind of one-time allowance thing, but probably we expect that most of the time you just enable the maximum and type the yes 20. So
yeah, but no, I see your point.
Okay, so the fun stuff now. The create, update, and delete flow by operator functions. So it's basically the same signature as create flow, except we have a sender in these. That's the only difference. Only the operator can call these functions. And this is also the same. Yep. And we also have two new events, a flow operator update event, which gets emitted whenever the flow operator gets updated for a particular sender, and also a flow updated extension, which will be used in our subgraph and added to the flow updated entity.
Can I interject two comments? One thing is, I think the permission, the flow update allowance probably is the one that are hard to use, and I'm not sure if actually people can make a useful semantic out of it. But I do imagine that separating permission would be useful, so that sometimes you want to limit the power of the operator, only allows it to delete flow, which is quite often a use case coming up. So it's allowing other people to close your stream. So separation of permission, I don't see a problem, but just the flow rate allowance is harder thing, or just a kind of reason if it's actually going to be used and how. So that's up for more comments here. Probably in practice, we would just set maximum, and which is quite questionable and can be dangerous. But yeah, C20 is like that. People doing that. So what can we say?
I think most people will probably just default to max.
You can always create an intermediary contract with set rules, right? And then give max to the contract. Always call the contracts. And
Yeah.
But it will face similar problem, I guess, when somebody else close the stream, and well, if it's super app, maybe it can track actually. I don't know. Interesting to think about. Another thing about the event extension. I don't know if you want to go to the details, but the reason now it's extension is because, backward compatibility, we already have a subgraph mapper, which need to support all the event. And we can't just, in ideal world, you don't care about backward compatibility, you just change the event signature, but then all our subgraph application would break. So this is a compromised approach to kind of keep the backward compatibility for now. So our subgraph would index both events, but they would update the same entity. So the entity would be, in the entity level of subgraph would be backward compatible. So no one would notice anything apart from certain point of time. There will be new fields in the flow updated events. But on chain, there's actually two separate events, and one of the events, which is a flow updated extension, would pop up after the upgrade. So that's why it looks strange. It might worth a little bit more comments about it, although the comments can be also quite messy, basically, the history of backward compatibility.
I put some comments in the implementation, but I might add some more later. It's quite okay. We can move to the implementation, actual code. So I think a good place to start is the storage layout, the new storage layout, some of the pure functions. So we're storing this in one word, and this is kind of what it looks like. I think we discussed this. Yeah, we did this just in case we ever want to expand permissions or for whatever purpose, right? And also you said something about it being more efficient this way. Yeah, these are just all the encode, decode, get operations, which are fairly similar to the existing encode flow data, decode flow data. So nothing new there really. The flow operator ID is the hash of API.encode, flow operator string, the sender, and the flow operator. And this is used quite a few places to store the agreement data. Okay, let's go to a authorize. Okay. So all of these authorizations and revokes are going to be done through the host contract still. And we wanted to maintain that pattern for this, where if you want to interact with the agreements to change the state, you have to do it through the host. And there's extra security, so we ensure that you are who you say you are over here, right here. Sender is current context.sender. You can't set yourself as a flow operator. I don't know why you would even do that. It's kind of weird, but I'm just not gonna let you do that. And then we also check if the permissions are clean. So this just basically means that you can't put any random number in for permissions. It has to be basically less than 7, less than or equal to 7. Yeah, and then we just call the functions to update the agreement data. So this is very similar to when we create a flow. We're updating agreement data, and then we're giving it the flow ID, full operator ID, and then encoding that flow operator data in here as well. And these two functions are wrapper functions. Like I said, we're just passing in to give the user full control, the max flow rates, and then also we're moving it here. Any questions, comments?
Maybe we could mention a bit about the usage of reason for the revert instead of the custom error in 0.8. So by the way, we already upgraded to using the solidity 0.8.
Yep.
So the reason we have migrated is because migrate to using a custom error is because how do we describe?
Oh, the call utils error. What's it called?
Well, yeah, the inconsistent behavior between different testing nodes. Like, well, you know that we are still using truffle, so it's Ganache. Ganache has slightly different behavior when dealing with custom errors, like panic error, this kind of thing. So those kind of edge cases still didn't fully resolve, so that we don't have a test case that consistently reflecting the correct behavior. So we haven't migrated it, but we tried, so failed for now.
But once
so
we switch to hard hat,
we'll see.
yeah, maybe
solve the, yeah, we'll see if it solve that issue. But yeah, that's basically the blocker for now. Yeah. Are you guys actually using Blockaway? Are you guys using a custom error already?
Yes, we are. I think Blago might be on something else, but yeah, we are. We're using Solidity custom errors.
Okay. Cool. The reason that we test in actually a lot of cases we're testing because of super app support. So when the super app revert with different errors, we want that error to be bubble up, like exception handling, to the upper level, with correct error messages. So that part support is a bit inconsistent in the Ganache implementation and the actual node, or even in Remix when you're dealing with the JavaScript emulator. So they all have slightly different behavior. They couldn't work consistently, so we kind of shelve it for now. So maybe when the tooling improve in a month-ish, we'll pick up the branch and eventually make it using custom error. So reduce the code size a bit, I guess. Hopefully it will.
Yeah.
Okay, that's just one comment about it.
So this is the create flow by operator function. And I refactored I guess all the change flow functions. So a lot of them held fairly similar logic, especially between create flow by operator and create flow. And I moved that into an internal create flow function. All the logic is pretty much the same, except for the create flow by operators. We just have to make sure that they have the actual permissions to create a flow as the operator and to update the flow rate allowance accordingly, and that the amount that they want to create for flow is allowed. Yeah, so that's pretty much the same here as well. The logic for the update is slightly different. So whenever you're creating flow, you're just subtracting whatever amount that they're trying to create, the flow rate. And when you're updating, you're changing it by the delta of the new flow rate and the old flow rate. But if the old flow rate is greater than or equal to the new flow rate, or the flow rate allowance is the maximum amount, it just remains the same. That's the only difference between create and update. And for delete, it's the same thing. We're just requiring that the user has permissions. If they do, then they can go ahead and delete flow. If an flow operator wants to call delete flow by operator to liquidate, they can as well. I don't know why they would do that. It costs more gas and costs more for them, but they technically can do that right now.
Sorry, can you check one thing?
Yep.
the error strings, is any of them exceeding 32 characters? I know that it's good to write in English, but can I check? I can do a sanity check of the 655. How many characters that? There's huge difference between 32 letters and more than 32 letters. Exact. How much is that? 52?
62.
Yeah, that's a bit wasteful, yeah.
So we should always be below 32, like something like this, right?
Yeah.
Okay.
That's why the idea is a little bit inconsistency than here, but the idea it's all using the kind of shorter string type of thing.
Because that just increases the contract size, right? And
yeah, if you have more than 32, it increases one word again. 32 bytes, it's a lot. So yeah, I would consider to refactor those out. Maybe apply the same strategy as IDA, just well until we do the custom error, right? So.
I think that's pretty much all for ACL. Like I said, most of the internal functions are exactly the same. They just are in a new place now. Yeah, I guess one thing that was kind of fun was dealing with this stack too deep. So adding the emit for flow updated, had to do some funky stuff. But anyways, yeah, that's it, to be honest.
And one of the things that are concerning was the behavior of for the app. So the app now needs to deal with the callback that who is actual message, flow sender. I hope the app doesn't use a message sender. Doesn't assume a message sender as flow sender. So because of ACL, that will be different. Right. So that has to be.
Yeah. It would be nice. Oh, sorry. Yeah, it would be nice maybe in the docs to have in the super app section to have maybe a recommendation or notes that you should be decoding the agreement data to get the kind of sender and the receiver of the stream to kind of do your own logic in the hooks, because this is sort of something we do. But I think people have made a mistake in the past. I think Ricochet maybe have done this in the past, but yeah, that could be nice.
Okay, cool. Yeah, that's pretty much all. If anyone has any questions, concerns, or whatever, please do voice your opinions.
So maybe an unrelated question, but I was going to ask, like, to which 0.8 version you did update the contracts to?
So our interface files are all, I think, 0.8.0 at greater than 0.8.0, and our actual contracts are 0.8.12.
Right. Okay. Sounds good.
Is there anything particular about the version you're asking, Robert?
No, not really. Just was curious about the choice.
Oh, I think in general, we could be very aggressively follow whatever latest for 0.8. From 7 to 8 was a little bit overweighting, but from 0.8 to any newer version, I don't see a problem. Usually we'll just keep updating it.
I just linked the release notes of 0.8.13 And there's a section which supposedly the stack too deep issue may be gone with that.
No way.
I didn't study in detail, but it reads like at least it should be possible to get rid of it.
So we can refactor the code to make all those ugly brackets go away.
Maybe.
No. Actually, we were discussing with Vincent a lunchtime that there's one Solidity feature that I wasn't aware of for quite a long time that maybe make some of the potential code organization chunks missed was actually Solidity allows anonymous function and function pointer, this kind of thing. You can pass function around, even you can define function nested way. I didn't know that Solidity allowed that.
Yeah, I also wondered if that could help with cleaning up the CFA code, for example. So to get rid of all these device branches or some of them.
Maybe, yeah. And one of the refactoring we will probably do very soon is split CFA into the storage independent part of the logic and the storage implementation in a subclass, subcontract or something. So the abstract contract of CFA will be much smaller, while the storage implementation will be in a separate file. It's just something that we'll can do the refactoring. But hopefully that function pointer type of feature, maybe I can also offer some code organization help. I don't know if any of you used it ever or extensively in your code.
I think I haven't yet seen it in the wild.
Yeah, it's unexpected that I thought that Solidity is a simple language, but apparently it's fully inspired by the Thug language JavaScript. Okay. Vincent, anything more, or was that's it?
That's pretty much it. Yeah.
And you don't want to go through the test, I guess. There's 2,000 lines of change, I guess.
We can look at the test if you guys want, but if you guys want to come up with more test cases with me, great.
Yeah. Yeah. So, well, that was short. I thought we had more code. So, any comments like by this design? Is that okay to go? Our plan is to code merge soon enough, and then we will start to develop peripheral support, including Subgraph, SDK. Yeah. And how would you guys use it, by the way? Okay.
Is that open question?
Yeah, is it something that you can use already once we merge?
Yes, I think we would pretty much use this immediately. A very simple feature we would want to do is free trials. So free trials, so you basically give us the allowance to open a stream or create a flow for you, and we would do that at the end of your free trial. Because currently, if you want to do this, you have to use messy meta transactions, stuff like that. And yeah, actually, when I think about it, Miao, the way you do the allowance actually makes sense. Like the one shot kind of thing. It's actually better than having this buffer you can continuously play with. But yeah, that's an immediate feature. And then there are lots of really interesting ideas we can do sort of a little bit later down the line, where I imagine you can fully delegate the rights to like an operator. We could even perhaps give you like a login with email password scenario for all the kind of some Web 2 customers. Like Fran kind of made a point. But yeah, this is going to be huge for us, and it's going to make our life like a lot easier. So thank you.
Cool. Good to hear.
Here.
Do you think you need anything peripheral support? Because from our side to consider it's fully down, we have to have the documentation, SDK support. It's trivial support, to be fair, but a subgraph also need to support the new event, which is to index the operator updating events and the new extension of the flow update. All these, right? So do you need those to go live, or you would use immediately just on-chain party when that is merged?
I think we're pretty ready to go. We don't use the SDK. The subgraph might be needed. Maybe I can correct me on this. That might be helpful.
No. I think,
good?
yeah,
Okay.
certainly will be helpful, but not really needed, I would say. I think like the main thing is the contracts. So once they're merged, I think we have everything we need. Regarding docs, we can go over the contracts, and I mean, if it's not written yet, we can derive docs from there. It would be just useful to know like around what time this feature is planned to be merged, so we can like take a look and ensure that, for example, we don't do anything that's stupid in regards to this feature. So I mean, like, to ensure nothing is broken on our side.
In terms of yeah, so one gotcha is basically the message sender in the update and delete, update and create. Make sure that if you have
we have that sorted out. We don't rely on message sender in any way. We use the agreement data, I think, to derive the account.
That's good. And which testnet you would test your stuff usually?
So we are testing stuff now on Mumbai. We have things deployed on Arbitrum testnet and Optimism testnet as well, but most of the testing was on Mumbai. So I assume like we'll test this feature there as well.
Would you share why it's on Mumbai? It's a very curious choice.
No, I think like it was Mumbai was the oldest version of the testnet, and we were planning to launch a Polygon at first. So Mumbai was like most native to that. But and also like deploying on Arbitrum was a bit weird. So the gas limit and that kind of stuff. But yeah, like no really strong preference regarding launch. We were planning like Polygon mainnet. I'm not sure like if that will stay. That will be the final plan, or we'll switch to Arbitrum or something else. But yeah.
What about optimism? You didn't mention at all. Is that something that?
Yeah, I mean like Arbitrum or Optimism, no really strong preference. From what I've know, like maybe my knowledge is a bit outdated, but Arbitrum had a lot more activity than Optimism, and like I remember like Optimism had like 2 or 3 apps, and it was quite permissioned at one point, not really up to date what's happening there.
Right. Yeah, from purely TVL perspective, that looks likely, but it's arguable still.
Right.
Okay, good to know. Yeah, so in terms of timing, usually we try to now have every 2 weeks release of the new contracts, and if there's big enough change that worth pushing to the mainnet, we would push. And for Polygon and Gnosis chain, I don't think we will have any. We will not sweat just to push it because it doesn't cost much. But for the Optimism and Arbitrum, they do cost a little bit. So we might want to not to waste too much money there, because each deployment would be around $200 or $300 or $400. Depends how many contracts dragged into the deployment for each network. So that's the current situation. Didi, am I right? You're looking for Arbitrum?
Yeah, that should be approximately the number.
So yeah, so timing wise, once the code is merged, you can expect that we can deploy to mainnet within a week or two. And we still plan to code merge by this Friday. And if there's no other hiccups, so if we need to separate the subgraph and SDK changes into a separate branch, we would still do it so that we don't block our Solidity code merge. So we can do something there still, because it sounds like that you guys are just wanting the contracts part. So we might adapt to that also, because you are the only known customer that actually use this feature. But I'm sure once we have a docs, stuff like that ready, I think more and more people can benefit from that, especially from hackathons, and new ideas can be created. Basically, it's very looking forward to the future actually.
Yeah, nice. By the way, regarding like the change, so as I understand, like Polygon is the most supported one in terms of Superfluid, right? Like first, when you release stuff, they go to Polygon first, right?
Before Optimum and Optimism, usually is XSty and Polygon, or Gnosis chain and Polygons at the same time, because it just the workflow, either we just go to GitHub and do 2 deployments, and instead of usually just one day, doing the same. Yeah, so it's the same. But going forward, yes, I would expect that less often in Optimism and Arbitrum, for the sake of not spending too often the deployment.
Okay, thank you.
Okay. Maybe I can ask Vijay, do I miss anything from product side we will actually do around ACL that I haven't mentioned?
Not that I can think of right now. I mean, I think you know, we still need to work on the different ways that we might choose to implement this around, you know, I guess like the kind of closed-ended streams and closed like fixed amount streams, and I think that's probably something that's worth talking more about, how we implement it so that we have a more standardized way of doing it across products.
Is it feasible to display that someone else created a flow for you on the dashboard?
I mean, I think everything's feasible, probably technically, but like I think the question is like, you know, what is the best people's expectations on how it should work? Yeah. With
our subgraph strategy, I think it will be a new extension to the subgraph events. Going forward, basically have a new field saying closed by whom, right? The operator, and it's backward compatible from dashboard perspective. So going forward, at some point there will be a stream that is closed by a different operator, as opposed to sender or receiver. Then the dashboard can easily choose to render it different, say it is closed by somebody else, by the operator. So that's the way we will think how we will implement in the subgraph in the backward compatible way. I would imagine technically it should be fairly straightforward. If we choose not to render it, then that's fine too. Actually, do we actually render the stream closed by whom, this particular detail currently, or just saying that the stream is canceled?
No, no, we don't. We actually don't. We don't even like currently we're not even properly telling people that it was cancelled or not. We just tell them it stopped, so it's right. Not clear that it was liquidated or not. I think that's one thing we definitely need to improve. I think indicating who it was closed by is another level of detail. I think perhaps we might want to point to the console or something for like deeper exploration of detail rather than make it immediately apparent to people that they should be angry at someone, you know.
Yeah. And Vincent, the extension flow updated events, does it indicate who is liquidator also, not only just operator? How about liquidator?
No, because that's technically the same person. But I think now that we're talking about that, I should probably add another property saying if it was a liquidation or not. That would make sense.
Yeah, and perhaps also some additional information to help data plotting of how long the account has been insolvent. I don't know if we should do it on chain, but currently we do it off chain, right? When we do an analysis for how long the account has been insolvent, and we have a plot graph of it. Yeah, that's might be something that worth mentioning in this forum is we don't have continuous monitoring yet, but we have a metric called Sentinel response time. So we could use a subgraph to measure that. So the idea of the measuring is that when the account goes to critical, and we can measure with the existing data for how long the account has been critical, and for how long the Sentinel, one of the Sentinels, start to liquidate it. So the delay of that is the response time, and we want to continuously monitor that going forward to see how strong our network is, the solvency network. And so far we observe that the response time is fairly fast on Polygon. So under 5 minutes, everything's liquidated. And there are a couple of outliers from time to time, but ideally there should be no outside of the 4 hours window. And so far the outlier are mostly within that. Of course, we are not doing continuous monitoring. That's something we will be building. So we'll know that our response time, if it's degrading or improving, and that can actually help us to adjust to the deposit window also on, liquidation period also on the mainnet, right? Mainnet has 4 hours. We were trying to be cautious, but going forward, when we start to have more data and start to observe that our response time is fairly reasonable, yeah, we could consider to lower it, at least on Polygon and Gnosis chain. On the layer 2 ones has other issues because of they might be stopped for a few hours even, so this kind of thing. So, but Polygon, the Gnosis chain should be okay.
Miao and Vijay, is Superfluid planning to release perhaps like a product feature of fixed term streaming? So I know kind of you talk about this. So now with kind of the ACL, you have the ability to close a stream on behalf of someone. So, okay, the tech is there, but now I guess it's just running the off-chain bots. Is this something which kind of you would leave to a third-party application, or is this maybe something Superfluid's thinking of building themselves?
I guess this kind of ties a little bit into the conversations we've been having recently, Miao, about how we want to move in this direction. I think we would like to be able to provide this as a feature. The exact means by which we're going to go about that is a little bit TBD. We're trying to work out what the best route is.
Yeah, I think probably general principle, what you could expect is that we usually don't create competing products, but we create technology that you can use, and you package it into a product eventually, like your case, right? So we create the technology and we deal with the customers and regulation and legal stuff, something like that. That would be the general direction. And for this fixed term stream, it's the most wanted feature also. So that, I mean, technical detail would be is decentralized or centralized. Is there an incentive network,
Yeah.
again? Is it built into the Sentinel, all these kind of things. So we are still trying to figure it out. But just in terms of, as you said, once ACL features there, anyone can build their ad hoc solution, right? So if we offer, we better offer something very solid and reusable, and so that can remove most of the pain from you building your own ad hoc solution.
Yeah.
We don't want to create an ad hoc solution that not necessarily better than your ad hoc solution. So that's why we're kind of taking our time to build a good reusable foundational technology.
Yeah, no, it makes sense. I mean, look, it'd be a nice feature. But I imagine if you want to do, and my intuition is you want to have some incentive mechanism. Maybe this is something the Sentinels could take part in, because maybe this is foundational enough fixed term streaming. It's quite foundational. Like this is more of a feature in my opinion than a product. So yeah, this is sort of it would be nice basically. But implementing that incentive mechanism, yeah, that could be interesting, but
Yeah, I mean, we talked about last conversation was about a tip mechanism, right? So you create a ACL, but with tips so that you incentivize our, currently it's called a solvency network, but when we have a such feature built in, maybe it should be renamed to something else, not solvency, but workers network or whatever. Better capturing the both functionalities. So that could be a direction.
Definitely.
But okay, so then let me ask you this way then. Would you rely on that decentralized network, or would you just build a more, no, let me not put that wording yet. So like not rely on the decentralized network, but your own kind of SLA guaranteed backend service that clean up the, so would you use a decentralized, or just, okay, it's sounding nice, we can build, but when you deal with the actual customer, you'd rather guarantee the service quality? So
yeah, I mean, look, there's two parts for me. Depends. Well, the answer is it depends. So from the company's perspective, we would do what's best for the customer and the product. Then, I mean, that's really the only thing that matters. However, also from as someone who's running Sentinels, you can see how this just kind of makes sense as well. Like it's a natural vertical, because I know from kind of previous conversations I've had with a few people that liquidations in the long run are not really going to be all that profitable. Or I'm not really entirely convinced about this. So, but we still want people to be running Sentinels. This is critically important for the entire ecosystem. So building small little avenues where there are certain ways to monetize, I think makes sense in the long run. Yeah, it really does. Yeah, that's kind of my opinion. I mean, if that's just a simple feature like a tip mechanism where you have fixed time streaming, or you could even go broader, like build like a resolver network in terms of the Sentinels. So like Gelato for Superfluid. So like you said, kind of automatic scheduling execution based on certain things. But yeah, does that kind of make sense? Yeah.
Yeah. So you're thinking on behalf of Superfluid Protocol? Yes, that makes sense. We definitely want the solvency network to be more profitable. We went all the hoops to build a 3P to make it slightly more profitable for like non-patrician, right? But if there is a separate feature that can rely on the Sentinels to make the feature work, the additional. Yeah, that makes sense.
Yeah.
But my question still stays: would you, as a company, still build a kind of backup? I mean, it's like Superfluid. We have backup services anyway, right? We don't fully rely on the Sentinel as a network.
Well, what we would probably first, not in the Sentinels in the current form, I'm not exactly convinced. Maybe if we rewrote the Sentinels, talked about this maybe in a different language, kind of multi-threaded, it's more systems oriented. But it's very hard to say, to be honest with you. It really depends what's the best for the product and what's the best service. So I wouldn't want to put any commitments out there. Yeah, it really depends.
Yeah, we're not trying to fish in your commitment. Just curious how you think about the issue, because yeah, from our protocol perspective, probably the decentralized way is more communicatable to kind of people running Sentinel, but I always find it a dilemma that when people building products, they go, oh, no, maybe we'll just not rely on that. We just have our own
Yeah.
system.
Yeah.
That's interesting.
Well, moving money on chain and having that be decentralized, that's critically important. But the question is, are these small like convenience features actually important? Is it important? Like some cases it may, some cases it may not, etc.
Even for the Sentinel itself, currently we still have commit to a trade-off with that we don't rely on subgraph at all. Sentinel currently is a subgraph free, right? But in a year or so, maybe subgraph node become an integral part of the Web3 infra, right? So it become a part of the node. Then we'll be then we will start to think differently. But I mentioned that because subgraph can be considered more centralized, right? The service hosted by the graph.
Quite actually on that topic, there's a few weeks, maybe months back, heard rumbles about Superfluid running your own subgraph nodes, because currently at the dashboard, at least this was the case some time ago, it can be really slow sometimes, like 45 seconds to just load things. Is there any updates on that?
No, we haven't managed to run the infra yet, and I'm kind of have a reservation regarding if we can run it better yet with the current team size. So because if we already had a headache for subgraph team to run that, it might be also headache for, I mean, definitely a headache for us also. So before we can fully using our solution, we'll first need to see that if we can maintain that infrastructure ourselves scalably. So no ETA yet, but that certainly would be nice. We were talking about today actually with Kaspar here. He's also here, is doing our SDK and subgraph part sometimes also. One of the feature about one of the limitation that we deliberately turned off a feature from Subgraph of Superfluid is the ability to update all the IDA subscribers data. So when the publisher do a distribution, we don't do a loop saying go over all the subscribers and update their state of the account. It's deliberately turned off because it is hard to understand if we will trigger some limit here, somewhere in the graph stack, right? Because it's open-ended. It's theoretical, I know, because our index don't really have, let's say, millions of subscribers yet. But just from a scalability perspective, going over 100, going over 1,000, going over 10,000, it's a very different thing. And since IDEA is fairly scalable from subscriber perspective, from a publisher perspective, we turn that off. And that ties to the conversation we're having here about subgraph self-hosting. So if we do want that feature, and we do encounter that the hosted version has a limitation, and we want that desperately, then we will have to do our self-hosting and tune the parameter and make it work. Although I'm myself is not super convinced that that's still the way, but just as a possibility. I mean, having a loop that has undetermined number of elements in the system. I'm not convinced that's the best solution. But if we do want that, then we have to probably self-host. That's the idea.
Makes sense.
All right, we have half hour left. Should we talk about something else? Or?
Sure. Meow, actually, Didi as well. Didi, so we had a fun conversation about sort of quadratic decay agreement. So a new way of, a new streaming agreement where a more generalizable streaming agreement, which is sort of a superset of the constant flow agreement. I guess the easiest way, if I may just share my screen, is just through a diagram. So I was just thinking of this a little bit in the morning, but this is the idea, is that you would have now a flow rate, which is a function of two parameters, sort of y equals c plus k over x. And what you can imagine is that if you set the parameter of k equal to 0, then you just end up with y is equal to c, which is the constant flow agreement. So c is sort of the base flow rate. You can imagine this is in the constant flow agreement, this is the flow rate you would enter currently when you create flow. But you also now have the ability to have this, the amount of which Alice streams to Bob can quadratically decay as time passes. And yeah, I don't know. I thought it was kind of an interesting idea. We have potentially cool use cases. For example, it becomes cheaper the longer you stream. So in terms of our end, imagine you're a subscriber, it becomes quadratically cheaper the longer you have your subscription. So you're being rewarded eventually until you hit sort of a theoretical limit, like a base flow rate. And this also reduces very nicely the constant flow agreement by just setting some few parameters to 0. Now, that was an idea. I'm not sure any thoughts on this would be great. But yeah.
Yeah, so we had a topic, so we had a call with the guys, I think from Osmotic Funding. I'm not sure if we have a recording of that. So it seems to me that at the moment the open question is which the formula should be, which is offered in such agreement. This is an example. This could be it, but the question is, okay, why exactly this one and not another one? And should we have an agreement which allows specific formula, specific function for the flow rate, or should we try something more generic? That seems to be where we currently stand.
So, yeah, so my comment would be twofold: how to prototype it, and manifolds actually, how to prototype it and understand the behavior and how use case of it. It's one thing, the research aspect. The other thing is practically how can we enable it in the V1, right? So I think one of the thing that we might need to start to enable is to enable agreement only for certain tokens. So maybe this kind of experimental agreement will only enable for certain tokens, like so that we don't leak the experimental thing to all the tokens that we might want to audit more and before hitting issues, right? So, but at the same time allowing experiments. That's one thing. The other part is that once we have non-constant different formula, this is a conversation I had in the morning with Caspar. It's exactly about it. So currently we could estimate at the site, right? So in Subgraph, when there's update, we can know that immediately when the account is going to run out of the funds. So we can actually calculate at site because we only have CFA and we only have IDA. IDA, even when we have GDA, it's the same. So we can already estimate immediately. If we ignore the scalability issue of IDA distributions, we can actually calculate when the account is going to run out of funds immediately, and Subgraph can already have assorted entities that makes a alternative Sentinel implementation almost trivial. It's basically query the Subgraph entity and finding the one that run out of balance and just liquidate them, right? So without the whole Sentinel one, the reading the web from Web3. And the reason it's done like that is trying to not be Subgraph dependent. But once you have this third agreement with different formula, then you have to consider, okay, when we have 3 agreements enabled for the account, what is the formula? What is composite formula for calculating when the account is going to negative, right? When CFA is easy, you divide net flow rate and down. But when you have this, you have to encode a different for composite a different formula into it. And the more you get, the more the formula gets complicated. It's still okay perhaps, but it's different problems. So
yeah, I mean, it all makes sense. I just think it could be really interesting in so many different ways. And there's also like, yeah. I mean, I guess so. Suppose you were just thinking out loud. If you're going to do a arbitrary streaming agreement, so money doesn't flow constantly, but it moves in waves or whatever. Like you can partition into two groups. Ones which kind of slightly increase, and ones which slightly decrease. Now there was something I said to Didi. I had real concerns about potential streaming agreements that increase or arbitrarily increase. So kind of where you could see quadratic growth in the amount of money leaving one account and entering another account. For example, imagine if Polygon went down and we had a streaming agreement of y equals x squared. The whole system could become like insolvent. The whole protocol become insolvent very quickly.
Yeah,
so
would have a runaway effect.
A complete temporary runaway. But then, Didi, I know you kind of made a point, maybe you could elaborate. So you think if we were going to have a growth agreement, you think setting kind of limits or kind of the maximum number of flow rate could be like feasible, like the maximum where this could go?
Yeah, I definitely think so. And I think that in general, with the current solvency model, there needs to be an upper limit. So if the flow rate function is something like proposed here, where it's decaying, just going down, that's not an issue. That's implicit. But for something which could also go up, I think that yeah, there needs to be also a mechanism which caps it.
Yeah, so I think that's where the definition of what actually I'm trying to define the superfluid spec, right? So that's where the improvement can be done, which is the specification about what defines a agreement liquidatable can be generalized. Currently for CFA, it is when the account is critical. But in the case that DB mentioned, a different type of agreement, the definition of a liquidatable agreement could be entirely defined by the agreement itself. Could be a limit of how much it has been distributed so far, right? So that could be a condition. And then the Sentinel no longer has an ad hoc implementation of, okay, when the CFA is liquidatable, by knowing it just in the code, but then we have could have a more generalized definition of, okay, this agreement is liquidatable. Sentinel just say, okay, and according to the on-chain function, view function, it says it's liquidatable, and then we liquidate it. And the logic is defined by the agreement itself, right? So I just want to complete one thing that I mentioned regarding how to prototype it. Maybe it's early to mention this. I'm very pro the idea of that we can prototype it without going to EVM solidity. So I'm writing a spec so that we can actually, a tool that we can experiment this kind of agreement just by concepts, by the abstraction first. So I'll show that tool at some point. So it's going to be in Haskell here, and we already have the constant flow agreement IDA TBA. Actually, it's called transferable TBA, transferable balance agreement. It's basically ERC20, but it's
I thought about that as well, like a constant transfer agreement. That could be, so it could be quite easy. You just override the real-time balance. You could do like fraud division over some period.
Exactly.
Yeah.
So basically, sorry.
No, go on.
So basically, the idea is to make a kind of general framework that has no exception like ERC20, but everything is included in the agreement framework, right? So you have TBA, CFA, GDA, then you have this quadratic flow QFA.
No, yeah. Look, I mean,
Tony, sorry, just wanted to mention something on the growing quadratic stream. one thing we thought is that even with the current solvency model, you can have a quadratic function as long as that quadratic function decays, right? So if you can't have an unbounded going up, but you can have something that goes up to x, if that makes sense.
Yeah, in the
Which is-
limit.
It
Yeah.
goes up, it goes up, but it goes up in a way that at some point it's basically becomes semi, closer to a line, right? And in that case, what you can do is that you basically have, you simply set the deposit as the upper bound.
Okay. So yeah, the worst case scenario. Yeah.
So in early days when we designed this kind of a non-linear agreement, so what you can do is you draw upper bound line, right? So you still use a linear function, but you draw in the upper bound so that your quadratic function never cross that. But not all the agreement is like that, right? So hypothetical ones. So
Yeah.
So there's no.
Yeah.
That was one of the ideas. So that yeah.
No, I definitely see the point. Meow, maybe one thing. So you mentioned like the constant balance transfer agreement, or in my mind it was called like the constant transfer agreement. But like, so, it's basically ERC20, but you do it on chain, like with real-time balance. So that has a lot of use cases that we could potentially, I think diagonal, that could be really powerful, because there are certain businesses where streaming becomes a little bit of a headache. Imagine an RPC provider where you get charged for a number of RPC calls. So sort of where you need to, basically you don't know, it's dynamically computed, the price. So the merchant doesn't know what they should charge until the end of the month, because they have to do a lot of off-chain calculations. In that case, having still some way to do this constant transfer and have it be on-chain verifiable revenue is really interesting. Yeah. So
okay,
that's something. Go on.
Sorry guys, go home. I need to go open the door. Continue on.
No. Okay. So Fran, you call it this SFA? Is that what you thought about it? So you guys must have thought about this quite a bit before.
No, I was just kidding, because Sonny said sigmoid functions. So I'm like, oh, that's the
All right.
sigmoid flowing agreement. No, that was just a joke. What you're saying is basically building like traditional monthly subscriptions, right? Or traditional, even just daily, right, settled ones. So the problem there with all the theoretical agreements, it's always the same problem, right? I mean, ultimately you can encode any function. The problem is always solvency. So it would be actually trivial to make monthly transactions instead of by the second. The problem is at that point you would need the user to basically lock a full month upfront, right? Which means, again, solvency is the bottleneck.
Yeah, I see your point. I thought about this. I don't think you necessarily would. You could still be capital efficient, because you would only you have to define some conditions, some restrictions. For example, suppose I have one payment, like a discrete transfer amount. Suppose that payment is going to happen on the 1st of every month. You could maybe set a rule set that you need to have enough capital for the transfer 24 hours before the scheduled movement. And then if you don't, you can get liquidated, or then you lose some deposit. But that's still
right.
Miles
so you still need
better.
A deposit.
Yeah, that's still fine. But that's still miles better than having to lock anything. And what's also tremendous about it is that it's on-chain verifiable. It's supported by a decentralized network of people who maintain the network and ensure the money always gets moved. Now, this is miles better than what some other people, let's say, might be trying to do, where you have just a centralized bot running this. So
yeah, for sure.
Yeah.
So basically you have a settlement window once a month or whatever, where users have to deposit the money at the beginning of the settlement. They lose a deposit of whatever amount, right? So the deposit would still need to be charged at the beginning.
That it would. But I think that's also okay. I think. But yeah, but look, it's an interesting use case. It definitely has real applications. We still definitely think streaming is a lot better in the majority of cases. But yeah, I mean, we're building real products for real people, so you gotta take things into consideration.
Sounds like I'm feeling increasingly a vibe that we should have some sort of summit for our Superfluid protocol or real-time balance, real-time finance, and it could be exciting to discuss all these ideas together.
That'd be great.
Yeah, and we are. I'm trying to finalize this framework where we can actually do experiments with new ideas without bog down to all the solidity or EVM crap, and we just experiment these ideas, and then we can solidify our concepts and ideas. Then we can bring that abstract concept and to on-chain perhaps next. Right? So hopefully I can present that framework soon enough. And as a showcase, I would take this quadratic flow type of thing as a fun experiments to use this to showcase that this framework can be used for fast prototyping new agreements. This is one example. Another example I always wanted to make it happen is a flow swap, which is adding time component to the Uniswap function, and then you can have a swap built into agreement. Hard to say if it's going to be useful in practice, but just to showcase agreement abstraction, and I think that's another thing I would definitely want to add. Yeah, soon enough, I'll showcase the toolkit. Hopefully, we can start to build more real-time finance agreements without hesitation.
Perfect. Looking forward to it.
Yes, sounds like a real-time finance summit, right?
Yes, I think it is. I think it is.
All right. All right. Summer or winter? Summer.
Yeah, summer.
Yeah, cool. Yeah, that's fun. Or anything else?
If we have some extra time, I'd like to bring something up that's briefly mentioned in our Slack, but I think this is a better forum. So I think we should consider the possibility of adding the NFT interface to the recipient side of a stream. Basically, giving the recipient of a stream rights access to transfer the stream to someone else. Now, this would effectively make every stream tradable. It breaks some semantics. It's not how kind of natural contracts work, because if I'm paying you, I don't want to pay someone else, right? I understand that. But it has some important implications. So to give an idea, what this would look like is that when you receive a stream, an NFT appears in your wallet, which says you're receiving a stream from Tony, and you have a transfer function. And if you call the transfer function, you transfer the NFT to Blagoy, right? So now the receiver is Blagoy, and the sender hasn't changed. So we're just changing the receiver, right? And I guess the main advantage is that building applications with tradable cash flows becomes a breeze. You can do things like start paying someone and then have that receiver assign the income to someone else, which means you can build applications that do loans on streams without forcing the user to go through that when they start the stream, right? Which is currently the case, right? At the moment, you would need to create a local contract. And if you didn't create that when you set up the stream, you can't do it, right? Which is a pretty strong limitation on applications built at the moment. So that's my main reason to do it. There is a secondary reason, which is a bit of a hack, which is the fact that ERC 721s are supported by wallets. So this would have the added effect of basically populating user wallets with NFTs for each stream. But that's kind of a second order value of this. But the main value for me is that it becomes much easier to build actual cash flow lending applications, or even, for something like what you guys at Diagonal built, building something that allows you to migrate to a new contract, right? If you want to change the underlying contract that does the intermediation of the streams. So these are some thoughts. I'd love to hear what you guys think.
My immediate reaction is, can't you just do this with a super app? Isn't this the kind of, you have a super app and you just make the super app an NFT and then you route through that. Now, Fran, as I know you know, there's almost, I think a lot of the very interesting applications being built on Superfluid largely follow this streaming NFT pattern. But if we move this to the protocol layer, so every stream defaults as an NFT, like it's cool. It's really cool, but
the main reason to move it to the protocol. So first of all, I think there could be some efficiency gains, but apart from that, it's because at the moment, the only way to do this is through a super app. And super apps, are whitelisted for a reason, right? They're complex, they're tricky to implement, and they are second, to do anything real, you need a second level agreement, right? You need a second level application, right? So imagine you have a tradable cash flow from your employer, and now you want to go to a lending market. You're going to transfer the NFT to the lending market, but that means the lending market can't be a super app. So I think actually adding second level applications is more complicated than what I'm suggesting. Because what I'm suggesting is, basically building in a transfer function which closes the previous stream and opens a new one, while building the second level applications has a ton of complex things that we were never able to really address properly.
I mean, yeah, it's cool. It's definitely cool. Yeah. I don't know. Anyone else got any thoughts?
That does sound a lot like the Supercard application. I'm just still trying to wrap my head around like how like the user being able to like transfer their stream to another entity would help with that kind of cash flow based financing use case. It wasn't very clear to me.
Yeah, so let me give you an example there, right? So imagine you're not using Diagonal as a user, right? You're the business, right? So the business that's using Diagonal is receiving a stream from a super app, which is receiving streams from users, right? Which means that the business that's receiving that stream can't do anything with the stream, right? All they can do is receive the funds. If the funds they're receiving were transferable, right? If the stream that the business is receiving from the super app were transferable, they could transfer that to a separate application that then could manage the extra logic, for example, right? If you're an employer, if you're an employee and you're receiving a stream from your employer, right? And your employer didn't set it up to go through a special product. They just send it to you. You can then go to that special product, transfer your stream to them, and initiate the loan process after the fact. While at the moment you have to do it at the time of initiating the stream, which is a huge bottleneck, because effectively, if Tony wanted to do it with their streams right now, he couldn't, because the Supercard application doesn't exist, right? And if then you wanted to change your loan provider, you couldn't, because you'd have to ask your employer to change the place where they send the stream to.
Yeah.
Do you see what I mean?
That makes total sense.
It adds flexibility basically to
I got
the
it.
receiver.
Is the downstream super app to super app streams, is that completely impossible? Is that sort of a problem? Because if we have super app to super app streams, then you can do anything.
Yes. Yeah, Meow maybe remembers the problems with.
Yeah, there are several ones. The reentrance issue. The other is how many levels we want to allow nested super apps, and the reentrance ones need to be really careful and make sure that we don't have. That's already quite a challenge to make sure that there's no reentrance issue when we have several level of callbacks. And how many levels? Kind of have a level concept already in the protocol, but we put it to 1. Basically, don't allow any nesting of super apps. Right? Allowing 2 is already.
Yeah, but yeah, the main problem, I don't know if you remember, was the attribution of failures, right?
Yes.
Like if there was a failure,
considered to be jailed, yeah.
Exactly.
Who do you jail? Yeah. So there's huge space of how to design the nesting. But in this particular case, an imperfect solution without even changing protocol would be just having an intermediary contract, non-super app that handles that, but allowing the inconsistent state that the user needs to recover, right? So user would receive from intermediary contract the stream, deposit still need to be paid by the intermediary contract. But if you accidentally close it, but the contract should provide a way but re-establish the stream to the one you want to transfer to. So not being a super app, but allow the contract to perhaps handle this kind of transferable stream per se. Right? So the contract being the forwarder by default to you. And as a business, you say, okay, I want to transfer that to somebody else. You go to the contract and say, okay, I'm deleting my flow and please transfer to somebody else. The contract can handle that. It's not as ideal as a super app from a certain point of view, but it's also clean, sorry, not clean, but not simple, that don't need an extra protocol feature. So that's the, if that's so wanted a feature, we might just do that, right? So, but if we want to talk about the protocol new feature of that, it sounds like a special case of ACL, but not, because it's not operator, but it's allow giving some rights to the receiver. We can think of it. But if we want building protocol,
right?
Maybe.
Yeah, it could be a special case of the ACL. Yeah.
As I said, if it's so wanted feature, we're not blocked. Create intermediary contract and without being a super app, and see if that can address the issue. Of course, the nice feature of super app being able to borrow balance, deposit wouldn't be there, but that's just a compromise, I guess.
Yeah, sorry, Tony, to add another thing, if you could transfer the stream, another thing you would gain is that you don't have to put up the double deposit, right? Because currently you have to put up double deposit if you do a tradable cash flow, which for some use cases is just infeasible, right? For short-term streams, you don't want to put out 8 hours of deposit. But if you were able to transfer it, then you could put 4 hours and still have transferability enabled.
Mm-hmm.
Right. I like the idea that Meow said of that being a special case ACL. I think that's the way.
The different.
And what are your thoughts when it comes to permissions? When it comes to these tradable cash flows, like if I were to, give my cash flow up to Supercard and start getting like cash flow based financing on it. I guess it would be, would I be like able to, pull back my income stream from Supercard, or would that be under complete jurisdiction of the Supercard contract? Is this like kind of a deal where you envision it would be like, okay, I give up my cash flow to someone and I'm not getting it back, or is it going to be like I can pull it back?
Yeah, I think that would be under the complete jurisdiction of the contract at that point, because the contract should have rules to release it, right? If it doesn't have rules to release it, you probably shouldn't sign up with them in the first place.
Hey guys, good stuff, really exciting. I think we should really plan that real-time finance summit. I think 2 or 3 days would be fun. And this is all the idea that we can discuss. Perhaps we should think about it already, just to have a roughly idea which is a month.
Yeah, let's do it.
It would be great. Right? It would be great.
All right. How about? Okay, it's too early to call for time, but something like in June, July, perhaps it'd be fun to discuss. I think good timing also.
Sounds good.
Somewhere in Europe or US, probably Europe for me. Okay, sounds fun. I'm gonna stop the recording now.